All right, so let's get started, guys. Ready? So, uh, this is pretty much starts statistics. This is the what's known as the normal distribution. This is just the distribution of the normal, or what's known as the norm of information. Hello. Um, the norm of information. So, like in a given, so like in a given in a given population, you have data or information falling within a certain percentage, which is known as a deviation of the mean, an average. So, say you're given an average of certain test scores in a class, in a class, right? Sorry, guys, I'm just checking the communication connection. All right, so say you're given an okay. So say you're given an average test score, and an average range of tests, or you want to know what the average of the class, or where the average of the class will fall, right? That's what's known as a normal distribution, all right? Or it could also be used for a population. Where does the average population fall given certain characteristics? So say you have characteristics like most people in this area have a type of hair texture, and you want to know what percentage of the mean does standard does is there a deviation? I mean, the best way of looking at this is to look at an example. Well, let me just start off by reading the question. Reading the first question. It says, many populations have a distribution that can be well described with what is known as the normal distribution, or the bell curve, right? Which is generally, again, the average, where the average falls. The average is supposed to fall, right? When you fall within a bell curve, everything's expected. Outside the bell curve, 1 or 2 standard deviations, okay. Way outside the bell curve, then your data is off, generally. So, um, so this curve, as seen in the accompanying handout to this lesson, shows the percent or proportion of a normally distributed data set that lies certain amount from the mean. For a population that is normally distributed, find the percentage of the population that lies within 1 standard deviation of the mean. Okay, so now let me just take you guys to this one chart right here. All right, so this is a normal distribution curve of any bit of information, if I'm not making that clear. test scores, hair type, a wealth, the wealth of a certain neighborhood would fall within this bell curve. Any statistical data will fall within a normal distribution. Any outlier, 1 to 3 standard deviations is okay. Once you go to 4 standard deviations, then it's really an anomaly. So this is what a lot of research scientists or mathematicians in general use to determine what's normal and what's out of place. I guess that's the easiest way to explain that. So if we look at that, so we look at the normal shape, we see that 68.3% is within 1 standard deviation of the mean, which the mean again is the average. You learned from Algebra 1, right? 68% of the data falls within the 1 standard deviation of the average, right? For me to define standard deviation it's a little bit more complicated. I think it would make things a lot harder than it actually is. We just accepted it as 1 unit away from the mean. 1 deviation away from the mean, obviously. Then if you look at 95% of any bit of data, it's usually 2 standard deviations from the mean. 2 sigma, as you see on the screen. And 3 standard deviation, you have 99.7% of all the information you could ever achieve for whatever you may be looking for, right? That's 99.7%. That's 3 standard deviation from the mean, right? This is the normal distribution curve. So if they ask, like in the first question, so if they ask, like in a question, within 1 standard deviation of the mean, we're looking at about 68.2. I know you guys can see that. So we're essentially just adding up all the curves, adding up the percentages from one deviation, which is going to be 34.13 plus 34.13, right? Within 2 standard deviations of the mean, you get what? You have to add 34.13 plus 34.13 plus 13.60 plus 13.60. Plus 13.60. Right? Then 3C says more than 3 standard deviations away from the mean. Well, more than 3, again, is going to be what? At 3 standard deviations, we're at 99.7%. So more than 3 standard deviations, we're looking at a 0.2 to 0.3% percentage. That would get us to exactly 100. Everyone see that, right? Does everyone understand that? Anyone have any questions so far on this? Anybody have any questions on this so far? Let me know. Then D says between 1 and 2 standard deviations above the mean. Between 1 and 2 standard deviations above the mean, right? So we have the mean, right? And then we want between 1 and 2. So between 1 and 2, we're looking at 13.6 right here. Do you see that? I don't know if you guys can see that. I'll circle it with my mouse. That's 1 and 2 standard deviations. That's 1 and 2 standard deviations. I hope that's clear. So I'll just continue on a little bit more. I'll do A and B. I'll try to do the rest of this. So it says, as can be easily seen from exercise 1, the majority of any normally distributed population will lie within one standard deviation of its mean, and the vast majority will lie within two standard deviations. A whole variation, a whole variety of problems can be solved if we know that a population is normally distributed. Again, we have to know that it's normally distributed. So which makes this pretty easy. The moment it says normally distributed, then you focus on this chart that you see in front of you, the shape of a normal distribution curve, right? Which is 68.3 for one standard deviation, 95.5 for two, 99.7 for three. Okay. At Arlington High School, 424 juniors recently took the SAT exam. On the math portion of the exam, the mean score was 540 with a standard deviation of 80. If the scores on the exam were normally distributed, answer the following questions. What percent of the math scores fell between 500 and 660? So in order for us to find what fell between 500 and 660, right, we would need to know, first thing we want to do is set up the mean, set up the normal distribution curve. How will that look? So let's go back to our chart right here. Okay, so we're looking right here, right? What percent of the mean scores right here? Let's see, this is 13.6. This is 95.4%, 68.2, and this is 0.3%, I would say. Okay, so what percent fell between 500? Okay, so for 500, right? First things first, let's do right here. Set up a normal distribution curve. We have a normal distribution curve right here. And it says that you have 424 juniors recently took the SAT. On the math portion, the mean score was 540, right? So we have 540 as the mean right here. 540, which was the average out of 540. 540, right? Right? With a standard deviation, so one standard deviation goes 80. So that's 80. 80 less than that, and 80 more than that, right? Plus 80 minus 80. So we're looking at hello. Yeah, speaking. Hi, Tony. Hey, hi, Tony. Yeah, I've been trying to get at you for a little bit. I have my hold on one second. Sorry.